Good morning, good afternoon, good evening, everybody. My name is Wim van Dijk. I'm a principal solutions consultant at SailPoint, which is just a very nice way of saying I'm a sales engineer. I've been with the company for about 4.5 years now, and I keep myself busy mostly doing POCs, custom demos, workshops, and all that fun stuff. So today I'd like to talk to you about how you can automate building IIQ and use it in your CI/CD pipeline, and or just use it for setting up your own development environment. I might want to make clear that I'm not going to tell you how to automate your actual development, as the title says misleadingly. So this is about automating your development setup. So what's on the agenda? I'll give a small introduction of what we'll be talking about. I'm going to go over a little bit of the tooling that is used. I'll give a high-level overview of how everything is connected together. I'll give a bit more of a detailed overview of the process, and then show what the project looks like and a little demo. And maybe we'll have some time for Q&A after. Okay, so today I'll see if I can answer any of the following questions. How can I spin up a dev environment in a repeatable manner, automate my IIQ deployments, reuse any existing DevOps infrastructure, or create nightly builds for testing, or all of the above? So all of this involves a combination of managing a VM in some way, building your environment, and managing your artifacts. So what kind of tools are we using for this? So we'll need a virtualization platform. For the purpose of the presentation, I'll be referring to VirtualBox, which is a great candidate because it's free and open source and installs on most platforms, but you can choose your own poison here. Vagrant is what we use to manage the VM. It will boot it up, and then in general is the central technology around which everything else is built. Ansible is used for the configuration of the host and installing and setting up IIQ, but as we will see, you can use any orchestration tool that you're familiar with. Packer allows you to create a baseline VM from an ISO file according to your own standards and specifications. It will be out of scope for the presentation today, but I mention it because it is often used in combination with Vagrant. The way to get these tools is very easy. On a Mac, you just use Homebrew, brew install, each of those. And similarly on Windows, very easy with Chocolatey. You do Choco install Vagrant Packer VirtualBox. You will notice Ansible is not mentioned on this page because there is no native Ansible available for Windows. However, if you want to test your playbooks, you can easily use a Linux VM for that, which is usually the standard. Technically, you don't need Ansible because, as you will see, we will run Ansible within the VM locally. And of course, if you're not using Ansible, this doesn't apply if you're using Chef or whatever. So a high-level overview. So if we want to just deploy a vanilla IIQ, the gist of it is that we automate a deployment of our application files into a VM that we then can also use in other repeatable automated fashions. So we take our VM, we take our installer files, we bundle our WAR file and deploy that WAR onto our VM, and we're done. So this is nothing unfamiliar. This is just a basic installation process, just that we're going to sort of automate all the steps. If you want to recreate an existing environment, it's very similar, except we add our exported artifacts into the WAR file before we import that and then load those during initialization. So again, we will first export our existing artifacts in the repository. Then we take our VM, the installer files, and then we overlay our artifacts over those installer files from a repository that we check out. We bundle our WAR file, we deploy it into the VM, and then again, we're done. So let's look a bit with a more detail at the tools that are used for this. So the brunt of the work is being done by tools that have their origin in the SSD, which stands for Services Standard Deployment. It's a set of tooling that has been created by our services organization that is used during IdentityIQ deployments and has been made available through Compass. And in particular, we're going to rely on what is called the SSB, which is a Services Standard Build, which is a series of file and folder structures into which you can export your artifacts and combine with automation tools and scripts that can build any custom code that you might have and then bundle everything together in a deployable WAR file. So we take these SSB scripts, we're going to do some stuff, and then we have profit. But more seriously, how does this all fit together? So, well, the SSB is going to provide us with tools to automate our build. And then given that these are just, in the end, they're all text files and scripts, they're all based on ANT, you can include this easily in any kind of existing orchestration. And then Vagrant, in its turn, allows to include orchestration when it gets a VM ready. So this means when it boots up the box, as it's called, Vagrant calls a VM a box. It boots up the box, and then you can finish up the setup by calling a provisioning step. And that provisioning step can then call your orchestration tool of choice. So in this case, we call, in this demo, in this example, we're going to call an Ansible playbook after it boots. And then after that, we use the machine, we can destroy it, and the process can start over again. So the result will be some sort of a Cattle-style virtual machine to use and abuse and reuse as needed. So again, we're using Ansible in this demo, but you can use any tool that you're already using or familiar with. So a note about Vagrant. This is in no way officially endorsed or supported by SailPoint. It is just the example that I'm using here to demonstrate how you could do this. So Vagrant supports many virtualization technologies out of the box, and for free you get VirtualBox, Hyper-V, and Docker. There are providers available for VMware and Parallels. So these are commercial products, and if you have a professional license for those, they do come with a plugin for Vagrant that you can install, and then that allows you to manage those as well. As I said, Vagrant allows you to provision into your boxes during a provisioning step when it boots up, and it allows for multiple methods. So we can provision using shell scripts, PowerShell, Ansible playbooks, CF Engine, chef recipes, Docker, Puppet, Salt, what have you. So anything that is out there that you can use as orchestration, you can use with Vagrant, so that you can reuse anything that you might have existing into your own demo environment. So after the first boot, Vagrant will call this provisioning, do whatever is required, and then continue with the machine. Then you can use it for whatever you want, and if you reboot it after that, it will just remain in the state that it's in until you destroy it and you start over. So again, I take a step back. We make our VM into a box. Right? This can be either pre-made with Packer, as I mentioned. So Packer, again, allows you to create your own VM according to your own specifications and auto install scripts. Or you can download one from the Vagrant online repository. They have official images that are published by distributions like Debian or Ubuntu. You can find Windows images as well. Or you can host one locally in your environment by having your own repository with local Vagrant boxes that can then be imported by your developers. So Vagrant up is what starts the process. It will boot the machine. After it boots, we're going to provision. After it's provisioned, we can use it for our testing, development, or demo. And once we're done with that, we destroy it, and we can repeat the whole process. Of course, because this is all scriptable, these are command line tools, it's all text-based, the same process can then be used to integrate this in your CI/CD pipeline, like Jenkins or what have you. So yeah, this is all well and good and a lot of fun, but what does this have to do with my own CI/CD pipe? Well, you can integrate only the bits you need, or you can integrate the whole thing. For example, you can just rely on the AND scripts that come with the SSB build and integrate those directly into your Jenkins, for example, using the AND plugin. You can just use a playbook that is used to orchestrate the installation of your vanilla or existing IIQ environment. You can build the Vagrant box and store it locally so that your developers can import it, or the developer can just roll their own and build it as needed. So, enough with the slides. Let's jump into an editor and then walk around the project and see how this works. Alright, I have my Visual Studio Code here. And I'm going to start the process already so that we don't have to keep watching scrolling text later on. So what we have here is a very simple structure. We have two folders, one for Vagrant and one for Ansible. If you're using Packer, you would have an extra folder here. So Vagrant uses what is called a Vagrant file. So that is where it keeps the configuration for the box. In my case, I'm using Parallels because I'm using Apple Silicon, and for the moment, VirtualBox doesn't work very nicely with Apple Silicon. So I'm using Parallels, and here I can set some very specific parameters for my VM when it gets created. I can set the name, I could set any other memory disk size things using the Parallels plugin. And then here we define the box, so the template of the VM. In my case, this is called Debian ARM because I'm on Apple Silicon, which is ARM, and I have a Debian image for ARM, which I have locally on my machine. So again, here you could put any name of a box that is publicly available on the Vagrant side, and then it will download it as needed and then boot it up. Or if you have your local repository in your organization, it will fetch it from that repository, copy it to the local machine, then store it as a template, and then instantiate a VM from that box. So in the end, a box is sort of a template VM, a vanilla snapshot, if you want, of a baseline. So we set some network parameters because we'll be using port forwarding to access our machine. We're defining how we can secure shell into it, and then we're going to mount these two folders into the machine, because then the next step, the one that we're really interested in, is provisioning. And here we define which provisioner we'll use. In my case, I'm using something called Ansible Local, which means Vagrant is going to SSH into the machine and then run Ansible on the local host. So here you could have define which scripts you might want to run, your PowerShell, your shell, your chef recipes. So in this case, we're using Ansible. So here we have an Ansible configuration. we're going to use this playbook. So in Ansible, the configuration of your orchestration is called a playbook, and a playbook contains roles. This playbook has some requirements, some roles that we're relying on that are external, and we can install those requirements with this command. So this will all be handled by this provisioner, as we will see in a second. So everything is being done by this playbook, so let's have a look at the playbook. So this is in the second folder. Here I have my playbook. As I said, a playbook contains of a bunch of roles. So in general, I have my VM is just a very bare Debian distribution. So there's nothing installed on there except the base OS. So we're going to have to install everything that we need. So these roles will take care of that. So we're going to bootstrap the other roles, install some core dependencies that we need, reset the host name, things like that. We're going to run a full update of all the packages of the OS. And then the things that we really need to run IIQ is Java, Tomcat, MySQL, and then of course our IdentityIQ itself. So these roles are external. I have not created those. There are people that are much better at doing that than me, and they keep them up to date. And each time this is run, it will fetch the latest versions of these roles, and you can tweak them by setting external parameters like this. I can tell it which Tomcat version I want to use, how much memory I want to give it. Similarly for MySQL, I can tell it which database to start with, etc., etc. Of course, this is all dependent on the role itself. Then, after all that, we're going to run the IdentityIQ role, which is, where the stuff happens that we're really interested in. So let's have a look at what that does. So the IdentityIQ step performs two tasks. The first one is we're going to build our WAR file, and then we're going to deploy that. So building the WAR file, we're going to use git and ant. So we use git to check out our repository. So this is my personal repository in this instance. So this is the file structure that is based on the SSB, containing the structure where we keep our artifacts and all the scripts that will be used later on to actually build the WAR file. I include a couple of custom rules and things that I like to have around for any vanilla installation that I do. So this would be the repository where you're keeping all your own artifacts with your workflows and your rules and your application definitions. So each time we're going to check that out, so you will always have the latest up-to-date version of your artifacts. Then we take the installer files. Those we have put in here. So this is all explained in the README file. All these files are in a Git repository. The URL for the repository is in the thread of the session, so you can go ahead and check those out. So you add your installer files into this folder with any patch files, any ETS files if needed. Then we put our own properties files into that file structure, and then we execute the Ant script that will build the WAR file. So this is the script from the SSB that is provided on Compass through the SSD, and it comes with a lot of Ant commands, and the most important one is how to build your WAR file. So this will take care of grabbing all of your artifacts. It will compile any custom classes that you might have, put them all in the correct file structure within the WAR file and then bundle it all together. So the result of this step is going to be the WAR file that will then be used in the next step is to install it. And that is simply unzipping the WAR file into our Tomcat application folder. We drop any existing database that might be present. We create a new one. Then we do some small edits into the create script for the schema. We create our IdentityIQ schema from the scripts in the installation files. We copy our own properties files over. We restart Tomcat. And then we do our import init and our import init LCM to initialize our installation. After which we can do any patching that is required by patching the file system, the database, and the IIQ objects. Then we restart Tomcat and we should be good to go. So in the meantime, I have started to run this Vagrant task, and let's see how it's doing. So when you run Vagrant up, as I said, it's going to take the Vagrant file and then follow the configuration that you have set up in there. So the first thing it will do, it will take the base box, in our case DB and ARM. It will make a clone of that and create the virtual machine. Then it's going to set up the network configuration that we defined. It will boot up the machine and wait for SSH to become available. It will install some virtualization tools that are required. It will do the same for VMware or VirtualBox. Reboot the machine, mount our folders, and then run our provisioner. So here we are inside the VM. We're running Ansible on the local host. So this would be where you would be running your shell scripts or your chef recipes or what have you. So first we're downloading all of the required extra roles, and then we're running the playbook. So we're setting up the OS, we're doing some bootstrapping, we're installing some necessary packages that we're going to need along the way. We update the whole OS because it's DB and we're going to use apt. After which we install Java. After which we install Tomcat. And it appears to be hanging on the download of the Tomcat archive. So this is where it would extract Tomcat and continue on to the MySQL installation and creating of the WAR file. And of course the demo gods are not with me. In the 10 times that I practiced this, this download went down in seconds. If you can bear with me, I'll just see if I can start this over. So when Vagrant boots the first time, it's assuming it needs to provision. So it will start the provisioning step regardless. The next time you boot it up, it will not do it anymore because it's not the first time. But you can always force a new execution of the provisioning by passing it the provision command. Alright. So the machine is already booted. And because Ansible is what is called idempotent, so the idea is steps that have already been done shouldn't be done anymore. So this is to make sure that you can repeat the process and not have to repeat tasks that have already been done, like install packages or create users or anything that is needed. So let's see. Okay, unfortunately, the network and or demo gods are not with me, because the VM is actually downloading the latest Tomcat source as it runs, and it is apparently not finding the Tomcat archive. So what I would have showed you after this is that it will install the WAR file, and then, oh, there we go. If we're lucky, we might still be finishing in time. So okay, we're going on to installing MySQL, and then after that, it will create the WAR file. So the idea of this whole thing is to show you a way that you can automate the whole thing. So when in my previous slides, when I said, let's take a step back. So in general, you have these SSB scripts that handle this for you. I have packaged these SSB scripts into an orchestration tool, in this case Ansible, and I've included my orchestration into a VM management tool, Vagrant, and then that will take care of the whole thing. Now, these are all different components that are easily integrated into other tools. So if you have your own CI/CD already, you can just pick and choose the things that you want, and this is perfectly repeatable. And had it not been for the interruption, it runs in under 9 minutes. So in under 9 minutes, you can have a fresh IIQ that has been built from scratch and is ready to go. And then maybe, I think I have a few more minutes. This might finish just in time. I don't know if there are any questions in the chat that I might be able to answer. Doesn't look like that. So yeah, I think we're basically running out of time. And we're about to run our import init. And all of these things are done by virtue of, in this case, Ansible. Ansible has all these built-in commands, let's say, where we can that we can rely on, for example, to use our WAR files and our jar files. We can simply use the built-in unarchive functionality when we want to run our import init. What we do is just we instantiate the correct Java class. So we run our Java console, and then we just pass it on the import init LCM, and then the same thing for the patching. It's pretty much an unarchive, and then we have some native MySQL commands that we can use, and that is that. So I think we have half a minute to go. I might just be able to quickly show you that this is actually working and show you a login screen of a freshly installed IIQ. There we go. I'll already grab my browser. All right, so it should be done. We're restarting Tomcat, and if I grab my browser, we have a fresh login screen. I have IdentityIQ 8.3 patch 2, and to show you that I'm actually using the files from my repository, I have a little rule that I always keep around as a sandbox for testing things. So this came out of my artifact repository, and in the end it took us about a combined 10 minutes to start from scratch have a development environment, I can now start using this, or testing, developing, destroy it, and then start over. So every day in the morning I can run this and have a fresh IdentityIQ. I apologize for that delay with the Tomcat step there, and I think I'm hitting time.